So in this section, we'd like to find the orbit in space. So particle can just only move on the planes from the conservation of the angular momentums. We find the orbit lies in the planes. Then we'd like to express these angular momentums in the polar coordinate. Sun is located at the origins. So this, if you consider this triangle, this x is r cosine f, and the y coordinate is r sine f, and the g is a 0. Then we can express x, y, and z. So if you find that x, y, z, x dot, y dot, z dot, this is r dot cosine f minus r f dot sine f. This y dot is r dot sine f plus r f dot cosine f, and z dot is 0. This is r dot. So this is r vectors and r dot vectors. Here, then you could find that angular momentum is directed in the g-axis, and the magnitude is a mu r square f dot. Then we'd like to find out the orbital plane in the space. To describe the orbital plane in the space, we need two angles, capital omega and I. Omega is the longitude of the ascending node. So it's an angle between the x and the ascending node. This is the angle. And the I is the inclinations. And to describe the position of the pericenters on the planes, we need one more angle of the lower case of the omega, argument of the pericenters. But to describe the directions of the planes, we only need a capital omega and the inclinations. And then we'd like to introduce the rotation matrix. We'd like to rotate Cartesian coordinate, xy coordinate, to the x primes and the y primes. And the relation between the xy to the x prime, y primes, we can express these ones. So we'd like to derive these relations. So for the r vectors, position vectors can be expressed r dot e sub x plus scalar product. This is scalar product, e sub y, e sub. If you consider e sub x, e sub y is directed on the x-axis and the y-axis. This is e sub x and e sub y. And the e sub x prime is on the x prime. So this is e sub x primes, e sub y prime. This is e sub y primes. Also, we can express this is r dot e sub x primes, e sub x prime plus r scalar product, e sub y prime, e sub y prime. Actually, this is corresponds to x. This corresponds to y. This is x primes. This is y prime. So we could express equation x e sub x plus y e sub y equal x prime e sub x prime plus y prime e sub y prime. So this is equation 1. So if you consider scalar product with the equation 1, is a x, e sub x. Then this becomes x, e sub x, e sub x plus y, e sub x scalar product e sub y, x primes e sub x, e sub x prime plus y primes e sub x, e sub y prime. Then this is gonna be 1. This is 0. This is cosine theta. This is cosine theta plus pi over 2. This is minus sine theta. So you can express x equal cosine theta x prime minus sine theta y prime. Okay, also we could consider scalar product y and e sub y. Then x, e sub y, e sub x plus y, e sub y, scalar product e sub y plus x prime, e sub y, e sub x prime plus y prime, e sub y dot e sub y prime. Then this is 0. This is 1. This is cosine pi over 2 minus theta. So this is sine theta. This is cosine theta. So it becomes y equal sine theta x prime plus cosine theta y prime. So we can express these two equations with a matrix x, y. It's gonna be cosine theta minus sine theta, sine theta, cosine theta, x prime, y prime. Okay, so from this equation, actually we discovered these equations. And the x, y, and the x prime, y prime is related with the rotation matrix. So if you consider the coordinate is rotated around the z-axis, then it's going to be, we use a rotation matrix. So in the case of the 3Ds, always rotation with respect to the one of the axis. So in this case, the g coordinate doesn't change. G prime equals the g. So we add these terms. So just we add this component. And then even in the 3D, it doesn't change much from the rotation matrix in the 2Ds. Then using the rotation matrix, we can express the orbit of an object in the 3D in space. So first of all, we'd like to rotation around the x-axis. In the case of the rotation around the x-axis, x doesn't change. Instead, y, z is changing. So we can change the rotation matrix in this way, new rotation matrix. Maybe if you really understand the previous part, you don't have so much problem to understand the rotation matrix. So using this rotation matrix, rotation around the z-axis and the rotation around the x-axis, would you like to express the orbit in space? This, okay, first rotation is rotations around the z-axis with the omega, lowercase of the omega. Okay, is an argument of the perisentence omega. And the second rotation is rotation around the x-axis, the angle of the eye. And this is rotation matrix we derived. So in this case, the x doesn't change. So this is 1. Then rotation, third rotation is the rotation around the z-axis of the capital omega, longitude of the ascending node. So by combination of the 3 rotations, actually we could express the orbit in the planes r cosine f, r sine f, 0. Using the combination of the 3 rotation matrix, we can express the positions of our particles in space. Okay, this is the end of this session.